Hello everyone! Today I want to talk about Prometheus, the open source monitoring and alerting system. You have probably seen pretty dashboards showing the metrics of your application, but it is always a bit confusing how the data from the application is propagated and what are the responsibilities of each element. So let's look today at the high-level architecture of the Prometheus. Prometheus is an open source monitoring and alerting system designed for distributed applications. At the core of the system is the Prometheus server. It periodically scrapes metrics from configured targets and stores them as time series data in its built-in time series database, which is stored locally on disk. Prometheus also exposes an HTTP API, which allows you to query metrics and integrate with dashboards and other tools. By design, a single Prometheus server is a standalone node. It is self-contained, it scrapes data and stores everything locally. It does not rely on any other nodes to operate. Prometheus is not a distributed system out of the box. If you deploy multiple Prometheus instances, they do not automatically coordinate or share state. However, this simple and robust architecture makes Prometheus extremely efficient and high-performing for many workloads. In case when scaling is still needed, teams often run separate Prometheus servers per region, cluster, or data center. Now let's move on to targets, the components from which Prometheus pulls metrics. Generally, monitoring systems follow either a push or a pull model. In the push model, applications initiate communication and send their metrics to the monitoring system. In the pull model, the monitoring system actively requests metrics from applications or other targets. Prometheus uses the pull model. It periodically scrapes metrics from long-lived services and from exporters. So what's the difference? Applications can expose a dedicated HTTP endpoint where they aggregate and return metrics in Prometheus format. However, not every system can expose metrics in that format natively. In such cases, an exporter is used. For example, PostgreSQL does not provide a built-in Prometheus metrics endpoint. Instead, a dedicated Postgres exporter connects to the database, executes queries, collects metrics, and exposes them in the Prometheus format via an HTTP endpoint. The same approach applies to Linux hosts, Kafka, Redis, and many other systems. Typically, an additional exporter component runs alongside the service and makes its metrics available to Prometheus. Now regarding long-lived applications, let's zoom in and take a Java Spring Boot application as an example. Spring Boot itself does not implement a metric system. Instead, it relies on a micrometer library as a metrics facade. Micrometer collects metrics inside the application and can export them to different monitoring systems. When the Prometheus registry is added, Micrometer exposes the metrics in the Prometheus format through the actuator Prometheus endpoint. This endpoint is then used by Prometheus for scraping the metrics. Going back to the architecture view. In the Prometheus, the push model is generally discouraged. Prometheus is designed around the pull model, where the server scrapes metrics from targets. However, there is one important exception: short-lived jobs. Batch jobs or CI tasks may run only for a few seconds, so Prometheus might not have time to scrape their metrics. In such cases, the job can push its metrics to the Prometheus push gateway. The push gateway stores these metrics temporarily and then exposes them via an HTTP endpoint. Prometheus then scrapes the push gateway like any other target. This allows metrics from short-lived processes to be collected even after the job has finished. So how does Prometheus know about its targets? Of course, you can configure a static list manually, but that's inconvenient because pods are constantly redeployed. Prometheus uses service discovery to update the list of targets automatically. There are a few common ways to do this. In Kubernetes, Prometheus can get a list of active pods and filter them by a dedicated label or annotation. The Prometheus config specifies which labels to check. It calls the Kubernetes API, filters the pods, and those that match become scraped targets. Another approach is file-based service discovery. Prometheus reads a configuration file that lists the targets. An external job or system like a CI pipeline, for example, updates this file whenever new applications are deployed. Prometheus automatically reloads the file and updates its targets. Now, once metrics are scraped and stored in the time series database, it's time to use them. Prometheus can detect problems by evaluating alert rules. When a rule is violated, it sends an alert to a special component called Alertmanager. Alertmanager is responsible for sending the alert to the right channel, such as Slack, email, or PagerDuty, for example. It can also retry notifications if needed. Alertmanager can identify duplicate alerts and handle them correctly. Deduplication is very important. Remember that Prometheus is a standalone server? For reliability, it is often deployed with one or more replicas. These replicas scrape and store the same metrics as the main server. Without deduplication, alert rules would trigger the same alert on every replica, resulting in duplicate notifications. Alertmanager prevents this by grouping and deduplicating alerts before sending them. And last but not least, dashboards. The Prometheus server stores metrics and exposes an API endpoint to query the data. Data visualization is handled by other components. One of the most popular is Grafana. Grafana accesses metrics through the API and provides tools for building charts, graphs, and dashboards. It's important to understand that Grafana does not store data, it only displays it. Grafana is not the only option. Many clients can query Prometheus directly using the API. One example is the Prometheus Query UI, which allows you to run PromQL queries directly in the browser. You can see current values, visualize metrics over time, and experiment with functions. It's also useful for testing alert rules before deploying them. That's it for today. I hope the video was useful. Thank you for watching and see you soon. Bye!